Okay, can you hear me okay? Yes, Defold. So thank you, Thomas, for the presentation. Don't think I need to go into this too much. But I could add that me and Christian worked on Defold for a very long time, and before that I was doing console games. So my background is more of a game developer than a game engine developer, as I'm doing right now. But so let's go into Defold. So as Thomas said, it's a lightweight game engine with a 2D focus, and lightweight means that it's a very small binary in the end, so it's very suitable for a tight device, handheld devices and so on. And 2D focus is that we have designed a tool set for typical 2D problems of those kinds of games. So it's still a 3D engine in the bottom, but it's more optimized for 2D problems. Obviously, it's scripted in Lua, that's why I'm here. So this means that the users who use the engine, they use Lua exclusively for making the logic in the games. And I will go into this much more in a moment. There's also an IDE, an editor, where you have visual editing as well as code editing. So it should be easy and visual for everyone to create the games. Even if you're an artist or a developer, use the same tool to make a game. No setup, so it's just one software that you download and it has everything you need included. It's also free, as Thomas said. Not Richard Stallman free, but free beer, more that definition. So this is what it looks like. This is the software, and right now there's a particle effects being edited there. So you can see you have some different tools available, like basic properties and immediate visual feedback and these things to make it really rapid to see the results. And also, of course, there's the engine, which is the player of this game content, which then runs on a cell phone or a native on the desktop, or also compiled into JavaScript to be able to run in a browser. So you can do web games as well. Okay, so the values behind Defold, and this is basically what has been dictating all our design decisions when we have made this engine. So performance is absolutely number one criterion, both performance in the final games, like frame rate and smoothness, but also in terms of workflows and loading times, size of the final packages and so on. So we think like performance is basically the foundation that everything lies upon. If you don't have performance, you really don't have any value in them. Cross-platform, as I just said, it's very important that it runs on all the platforms we target, and it's also important that it's able to run on all of them without being modified. So there's absolutely zero porting needed to run on any other target than the one you have previously done it for. Obviously, you would need to do something. You want to access some specific feature of that platform, but if you just make a game, it can run on all the platforms I mentioned before. Iteration is about creativity, and you really need zero iteration time to be able to creatively change and experiment and test stuff. So we always measure it in sub-second times. So everything from building the game and testing it and see the changes and on, everything should always be less than a second, because as soon as you have waiting times, you really get frustrated and depressed and not very anxious to try stuff. Collaboration. We use Git for this, and we also packaged it, the usage of it inside of our application. So it has a easier interface for Git, but it's still just a Git repository on the hard drive, so anyone can access it with command line tools if they wish. Short and long term. This means that it should be fairly quick to start it up and start using it, but also to be able to finalize and ship the final game. So it's not just a toy, but it's not either a very complex thing that's hard to learn, and we try to find a good balance between those two things. And so the sum of all this is to enable the users to focus on the game, and developing the game. So rather than having to deal with all the ins and outs of a specific platform or the problems of finding a good workflow, all of this should be already done. So the final problem is only to find what's fun about this game or what makes it worth people trying. So why did we choose Lua as the scripting language for this? We're of course looking at a few at this time. It was around 2010, I think, and the performance was really a key factor with Lua. It outperformed all the other ones, and then later on we saw the Lua JIT work and was really excited about that as well. So that has been really helpful. Also the size, since I'm talking about embedded platforms and so on, it's really attractive for us to see a 60 kilobyte virtual machine being able to be integrated, not bloating up the binary too much. The ability to reload code, I think, is crucial. I will talk more about this later. But I mean reloading code into the running application, so without restarting or doing the whole compilation cycle. Also simplicity. It's obviously designed from the perspective of letting a lot of people be able to use it, and that was also a very attractive part for us. We have our ambition is to even let artists and designers, people not familiar with programming, see all this Lua code and look at it and say, maybe I can change this, or maybe I can even change a number and just see what happens, and then be able to progress into programming as well. So how do you use it in the engine? What do you use it for? What purposes? Game logic is the most common thing. And by game logic, I mean the high-level logic of a game. So something happens, maybe a physics collision or an animation being completed, and then the game needs to say, okay, now we need to increase the score value, or we need to start a sound playing, or we need to do other stuff. So Lua essentially listens to the engine, input from the users and so on, and tells the engine what to do next. So it's more of a high-level thing. Obviously, you can still use it for things like procedural animation or movement of things, which is then every frame, but obviously it doesn't scale well enough there to support, big-scale games because of performance issues. UI, that's more all the status appearing on the screen telling about the state of the game. So maybe there's health bars, all these things, and the requirements for them is a bit specific in terms of changing the size of the display, how they lay out themselves and all of this. So that's also something we use Lua for, a bit more specific use case than the game logic. And also rendering itself. So I'm talking about the rendering pipeline here in OpenGL. So that's also scripted through Lua. Now I show examples of these things in a bit. And to let all this Lua code communicate with the rest of the engine and also all the other Lua code, we use message passing quite heavily. And that is a means for us to facilitate this communication but also keep separation. So it allows us to do parallelization and other things with the engine. We can control the usage through that as well. Also, of course, all the extensions, so Facebook integrations, in-app purchases, there might be tracking, server-side communications, all these things is, for example, exposing HTTP or sockets or stuff through Lua so people can do a bit what they want with it. We don't use it for more lower-level things like loading single resources. I've seen that's quite common with the Lua-based game engines, but that's more of there's other systems in place for that. So here you sort of tell such a system to, okay, load this whole big thing of things instead of this specific image or this specific sound. So let's look at some code. My apologies for the syntax highlighting. That was me playing around in the software. So first of all, we have an engine hook, and that's a function which is identified by its name. So this is on message. The engine will call this as soon as this particular Lua script receives a message from anywhere in the engine. And so then we see that we're checking for the message to be of a collision type, and also if the state of this script is now falling. And then we do the message passing I talked about. So here I have nicely wrapped up the message passing in some other functions through these APIs. So as you see, we do some landing, we play some thud kind of sound and start some dust. And then we switch the state of this thing that we're now controlling. So as you see, it's very high level, it's quite simple. This is not character by character identical to how it looks, but I simplified it a bit for readability in the presentation. This is another example when we instead look at rendering. So if you're familiar with OpenGL, you will recognize the first 3 lines, just controlling the GL state. And then there's something different in the bottom, and that is to, we could not do drawing at the element level through Lua. It doesn't work for that, doesn't scale. So what we instead do is that we let everything that is drawable tag itself with different values, user strings. And then in the rendering, you draw all these things. And this also makes a lot of sense when you're dealing with both 3D and 2D, that you would have, for example, shadow casters, or you have different purposes of these lights, for example. And so it's more of a batched rendering. So there's never much calls going on, Lua calls, when you do the actual rendering. It's mostly one set of constraint calls for the setup, and then you just draw. So what about message passing then? This means that everything must be addressable in the whole engine. We didn't want to do the traversing of the whole hierarchies of things inside of it. So need everything to be able to address everything at once, sort of like how the World Wide Web works. So we also solved it with a URL-like data structure in Lua. Very similar syntax, but slightly different. So instead of the protocol, we have a domain that's sort of like a world or a context of things. It might be physics, it might be game objects, which is the logic of the game, or rendering, for instance. And then we have a slash-based path, not too exciting, and also a final component, which some systems use to be able to even further distinguish things. We also need it to be convenient to communicate with things that are in close proximity to you. So there's also a partial thing going on here. For example, you could just specify the end part, the component part, and it would assume you're looking for components within you or within where you are. So the closer you are to things, the easier it is to communicate with them, sort of like friends or people. Message passing in itself is always passed by value and asynchronous, and this is for the same reason as I talked before, to be able to parallelize or separate things more. And the Lua state. We started off with 3 separate Lua states for these things I just described, and we just reasoned that it would be good to have this separation, and that people would want this, and that we would be able to expose different APIs within these 3 different states, which would be easy for the mental model of things. But that was a mistake. So we had to change this to a single shared state instead, because all the complaints, which we finally agreed with, especially motivated by when you have large shared globals. So if you load a lot of level data, for instance, you don't really want to load this into each of the separate states to be able to read it. You just want to load it once, and it doesn't really make sense to pass such data through message passing or anything else. It's essentially just a lot of data. Also, usability is also a very important factor, and people would assume that when they declare a global variable, they would be able to access it from all the Lua code. But we still kept the separate states, so it's a checkbox now if you want a shared state or not. So I was not myself very used to Lua when we chose it. It just looked very attractive on the paper, and now I have been able to use it more myself, and also worked a lot with integrating it and looking at its source code and so on. And I must say that the biggest benefit is the simplicity of it, and it's hard to explain this one, but what I've seen is that since the language itself is so simple, it tends to encourage you to solve your problems simply, rather than what I've seen and done myself in languages like C++, you tend to use the complicated language features in the hope that it will solve your own problems, while you're just fooling yourself, making something complex because you think you need it. And I never saw that when I looked at people's Lua code or my own. Things tend to become very simple and very uncomplicated, easy to read, easy to understand what the code does, and very clean. Once you reload, you never go back. Now I always have a problem when I'm working in languages. I can't reload live into a program because it's just such a great thing to be able to do. It's really a source of creativity and being flexible and testing your code in different ways. And coroutines. That was also very unexpected. I wasn't familiar with them before, but it turns out that they are amazing for some cases of game development and also, of course, many other things. This would be an example. So this is asynchronous code looking like it's synchronous. And this just, who doesn't love code that looks like this? You see that it's waiting for a half a second, show some intro. Wait for a touch, or maybe abandon that in 5 seconds. Show happy flower and erase the disk. Okay, so let's do a demo. So here we have the program running. I have split it a bit to be able to show the game it runs as well. It's just a small little demo we did in the team. Nice intro, of course. And so it's a neon shooter. It's a fairly popular thing, popularized by a big title on the Xbox 360 Live Arcade a few years ago. But the nice thing here is that a lot of things are going on, as you can see. It's very a lot of post effects visually and things like this always requires a bit of tweaking. So it might be hard to just look at it, restart it, and tweak the graphics. But if I can freeze it, I'm in a much better position to look at an interesting scene like this. And also, if I'm able to quickly control this, I might be able to show different stages of this compositing. And when I go here, for instance, I can see how the back grid is lit up. I can see here how the blurring works and so on. So let's put that here. And if we now look at this code, you see it's ordinary Lua. And these modes I just toggle with. Of course, that has nothing to do with Lua. I can do that anywhere. But in this case, it is Lua. So I'm also able to see here. I happen to be in the blur phase. And I'm using a set of render targets here. So I can see what they look like. So this is a much more blurry one. And I can make sure that I'm happy with how they look visually, and then being able to quickly see what the final compositing looks like and inspect it in this way. And I can also, if I come new to this program, I can use it to see what things does. So we have some background here. I'm not sure what happens if I remove that. Okay, that's clearing of the screen, so now we just snaky instead. But the cool thing now is that now I'm able to quickly do these things without stopping the program. And if I pause, now you see that I have a trajectory here after the thing moving. So I can even use this to see, okay, am I really happy? It seems to be very twitchy. There it stops, for instance. And I can inspect how things move, and it's just something that happens. And I don't mean this as a specific use case, but just an example of what happens when you're able to change your software and just reload it. Since this doesn't cost me anything, it doesn't cost me the need to restart or anything. And then, of course, I'm sick of this, so let's switch back. And also, I can have a look at the spaceship in this instance. So it seems to do something here with updating targets, updating threats. So if I stop updating threats, it will just blindly not avoid anything, just run into stuff. And then changing this line here, it will sort of not know where to go at all. So just as an example, how to be able to inspect, quickly find errors, quickly do tests. Maybe I'm having a bad frame rate and I want to see is this the GPU drawing too much. I can quickly just change the GL state and see that, no, that's not the case. I must be doing something else or profiling in different ways, doing what-if tests. Let's go back here. All right, that was sort of it. I'm open for questions now.
Do you support, or is it possible for users to write their own extensions for the tool and for the engine?
Not yet. It's there's a lot of time spent on it within the team now. So we're both the ability to extend the engine, the editor, and the content pipeline. So you have the full bridge. You can essentially put in your own stuff into it. But it's not completed yet, so hopefully it will come out Q1 or something like that. We will probably start with it, internally a bit first, but when it's mature enough for a public usage. Let me know if you're interested in beta testing these things. Anything else?
So the live reloading looks really cool in there. How do you handle sort of not blowing away the state you care about when you reload things into the engine?
So you mean how we actually deal with the Lua state essentially when we reload this code?
Yeah, your variables and your state on where things are in the game when you reload the mod.
Right. So it's essentially, let me see if I can find this here. So you see the self table here. This is just a table for persistent state. And so all the code here is reloaded, all the global variables and everything, except for this self state. This is attached to the specific game object or instance that this script now controls. So that will stay intact. And of course that means that if you affect this state and reload the code, you will mutate it and deal with it in this sense. But we have also introduced a hook which is called onReload, which means that in there you can do reset or you can do specific things. So when you actually reload the code, that function will be run, and that means you can go back or you can make specific changes. And all of that also means, of course, that you now have a dynamic workflow on your hands. So you can really specify, okay, I want to move this ship over here. I want to put these things up every time I reload, and just make it like a little start sequence of that, or just use it as a very quick key binding. So just reloading for the sake of running code. It's also possible. Was that a good answer? Yeah.
Is there a reason that you haven't done this as a coroutine instead, as an iterator of messages or something?
You mean these calls?
Yes. So why the on whatever hooks rather than say a coroutine that iterates of messages?
Oh, you mean the fact that we compare by the message ID by?
No. Just the fact that an on message function exists. Why not for message in game messages or something, and iterate over messages that way?
It still needs to be some kind of hook that the engine can call into, right? Some kind of start function or something that would be supplied these things that you talk about then, or all the messages, or?
No.
Maybe I'm misunderstanding the question.
So I suppose it's because of the way your engine possibly works.
The messages themselves are nothing more than small structs which have a message ID, and these are just values in the engine, so they can come from anywhere, they can go to anywhere. Then they get translated into Lua at the specific point that it's detected that the receiver of the message is a Lua script. So that's when we sort of switch it just to be able to interpret. So the message parameter there is where we have taken such a struct and converted it into Lua tables, so it should be easily read by this code. Not sure if that.
Don't worry.
Okay, let's discuss afterwards. Niklas.
So the messaging system you use here, it looks pretty much like the actor model that you have in airline, for instance. So that makes me sort of start to wonder if you it seems like you would want to put these things on different threads and get multi-threading in Lua that way. Is that something you're doing or something you're planning on doing, or
there was a big, it was a big reason for the architectural decision at first. But then, and it also meant that we have that ability whenever we would choose to do it. But back then, the low-end spec that we were working against was a single-threaded machine. So since it had to work for that machine and be reasonably fast, we really didn't have to parallelize anything for a long time. But since now we're looking at maybe lower frequencies on a multi-core or something like that, that has become a thing again. So yeah, probably we have to do something with that. And the original idea was to be able to parallelize even, among different Lua scripts, for instance. But we have also, for usability and other reasons, we have sort of cancelled that opportunity by means of other design decisions. For example, scripts being able to call into and read from write to values in others just for usability instead of message passing. But it's still possible through, rendering, game logic, these things.
Yeah, another question about the message passing. When you send a message, when is the on message hook called at the other end? Is that called automatically, directly, or is it called later when the receiver wants to get it? Or
yeah, it's asynchronous. It requires a bit of a lengthy explanation, but I'll try to condense it as much as I can. So the engine consists of what we call components. That's the meaningful stuff. It might be a Lua script, it might be a sound, whatever. And they are updated in batches. So first we might run all the Lua scripts, then we might do all the processing of animations, then something else. So it's one batch after the other. And some of these might produce messages, like the Lua scripts, for instance. And so after each of these batches, we run all the messages. And that in turn we call this function. So we empty this queue. But since this function is also Lua, it can resend. So that means that we might have more when we have parsed all of them. And so we do that 5 times, an arbitrary number of times. 5 is the current value of that, which would then try to exhaust this system. And then we move on to the next component type, update that, and try to clean out them again. So in effect, we do it more than 5 times over the whole frame because of all the different component types.
so messages that aren't processed in this 5 loops, they're left in the queue till the next time.
Yeah.
So you're not losing any.
Yeah, exactly. So if you would ping pong, like just send, resend, then that would work, but it might inflate the amount of messages, like not. If you do it that much enough, you would hit some buffer at some point.
So you said that you could sort of access game objects like directly if you wanted to, but if you wanted to do like strictly message based, then you would have to sort of construct a message, and that might include like creating like a table of message data and then sending that, and then there's a function call, and then the function call you have to branch to figure out what messages was. Have you noticed like any performance issues from doing that?
No, none actually. The reason is that there's so few of these happening. If you look at every frame of the game, the fact that something like this even happens is rare in these frames. And when that happens, there's not so much that goes on in there. So I think that's the reason. Of course, it means that there are spikes at these points, but the spikes themselves are not very noticeable either. So it makes a jagged curve of performance or cycle count essentially. But no, we haven't seen that. That has never been the issue for the games.
Do you feel that introducing global messaging system will introduce issues in the game code? So for example, you're able to communicate within one game object to a completely different system in another game part, and like in the end result it may end with really bad code quality when you, I don't know, when you move an object and then in the same function call you disable any UIs over that can be really problematic.
Yeah. We started that way to try to foster the users like that and cut off these things. But then we realized that it's a terrible design attitude to do that, because you also have to trust the users to be able to take mature decisions and be able to do stuff like that, like having global variables or being able to from here point into something completely foreign and say, I'm now changing this into something else. That also opens up for quicker testing, or if you want to do, like, I need to just try this out to see if it works, and you don't need to construct all these things in between or do it clean and beautifully, but it enables you. So it's more that now we allow basically everything. Like, you can create very tangly relationships between things because of the addressability of everything. But we trust that people won't exploit that there will be some sense in, wait a minute, because it's, as I said before, it also means that you have to absolutely specify these addresses of them, which will be longer and more complicated. So that in itself also creates some friction to do that, but you can if you want.
Another question. When you pass a message, as far as I understand, you can send some data with it. And you're not just passing a reference to the data, you perform some operations, because I tried passing really huge tables and something with, for example, class built on top of meta table, and default cuts off all the methods that are implemented inside the meta table. Was there any specific reasons to do that? Because it's kind of motivates you to use shared states, and then it also kills the point of message passing. Because if you can't pass any data through messages, why would you do messages at all?
The point of messages, I think, is not to pass anything that resembles logic or anything like that, but more pass values. Like, it's essentially a data communication. So what we strip out, for instance, would be functions, and because that's essentially logic. And also for the fact that the message passing is a global system of the whole engine, and what makes sense for a Lua program to interpret and read doesn't make sense for another part of the system. So there is a serialization of this Lua table down into something that is a readable format. So it's just data, and I think that's also key for message passing. It's also the good thing about the web, for example. If we at some point we used to send functions to each other, and that was not such a good idea, it turned out, in then remote procedure calls and the like. It's better to send data. Any other questions? Okay, maybe my time is up anyway.
Yeah.
Okay, thank you very much.